This is the first video in our series on factoring. We're going to be dealing with the greatest common factor, or GCF. So the big idea here is we want to find the biggest expression that we can divide evenly out of every term and then factor it out. And this expression is going to come out in front. So you're going to start out with a polynomial. You can have any number of terms. In this case, I've got a 3-term polynomial. You'll notice that after we factor out a GCF, you have the same number of terms. Also, the signs will remain the same. When pulling out a GCF, we want to look for the coefficients and constants first and ask the question, what's the biggest number that you can divide evenly into each one of those? We also want to look at the variables, and we want to be asking ourselves the question, what's the largest number of this variable, x, or whatever the variable is, that you can factor out of every term? This last point is really important. You always need to check after factoring to see if there's some other factor that you could have pulled out that maybe you missed when you did it the first time. So we're going to start with the following example. We've got some pretty big numbers here, 48, 234, and 30. So the first question I'm going to ask myself is, with these coefficients, what's the biggest number I can come up with that goes into each of those? Now I know they're all even numbers, so I'm going to go ahead and start by pulling out 2. Anything that's even should be divisible by 2. I'm going to look at my values of n next. Notice that there are n's in each of the terms. In fact, there are at least 2 in every term. So I should be able to factor out 2 n's from each of these. All right, let's figure out what's going to go inside here. So when we do this, when we figure out what's left over, first of all, there are going to be 3 terms, and the signs are going to remain the same. We need to divide out. So 48 divided by whatever we pulled out in front, 48 divided by 2 is going to give us 24. N to the 4th divided by n squared, we're canceling out 2 of those n's, we're going to have 2 left behind. Okay, 234 divided by 2 is going to give us 117. N cubed, when we pull out 2 n's, we're going to be left with 1 left behind. 30 we could divide by 2 to get 15, and when we divide out that n squared, we will not have any n's left over. So this is what we get after we pull out the common factor 2n squared. Now we want to check and make sure that there's nothing else that can be factored out of this. I'm going to look at my coefficients that I have left in here one more time. 24, 117, and 15. And I think I may have made an error, or at least I didn't get the biggest thing out that I could have, because those 3 numbers are each divisible by 3. So it looks like I probably could have gotten something bigger out, but that's okay. What we're going to do is we're going to stick with the 2n squared that we started with, but we're going to actually bring a 3 out in front as well. So from this last step, if we were to pull a 3 out as well, so I'm dividing 24n squared by 3, that's going to give me, 8n squared. 117 divided by 3 is going to give me a 39n, and 15 divided by 3 is 5. Let's check one last time, make sure we didn't miss anything. Anything that goes into 8 and 39 and 5. Well, 5 is a prime number, so the only thing that goes into that's 1 in itself, and 5 does not go into 8 or 39. So looks like we are done at this point. So we finish this problem up, we would go ahead and simplify this. 3 times 2n squared is 6n squared. Final answer is going to have a 6n squared out in front. We'll have an 8n squared plus a 39n minus a 5 left inside, and that'll do it. Now, if I'd been a little bit more careful at the beginning, I could have eliminated both of these steps here. If I had, when I started out, if I spent a little bit more time trying to find the biggest number that went into these things, I would have noticed that 6 does go into each of these numbers. We could have gone directly to this answer and gotten that much quicker. There are additional examples in the video with multi-step factoring. You'll see some additional examples over this topic.